In this video, I'm going to go through the answers to the Specimen Paper 1, the 2014 release for the IB Math Studies exam. I'm going to have my calculator up on the screen the whole time just in case we need it. And I know that this is a CAS calculator that you're seeing. Just remember that you can't use a CAS calculator on the exam. This is just the software that I have on my computer, but I won't use any of the CAS features as we go through this thing. Okay, let's look at number 1. We have a frequency histogram given to us for the distribution of time of telephone calls, and we're just first asked to fill in the frequency part of the table. So they show us that each bar is a class, right? 0 to 5, 5 to 10, 10 to 15, and 15 to 20. And we just have to figure out how high the bar is for each class. So it's pretty clear. The first bar rises to 12, the second one to 4, the third one is up at 6, because that's halfway between 4 and 8, and the final one is up at 8. And if you're unsure or you want to be really careful while you're on the test, you will have a ruler at your disposal, so you can just line it up against the top of the bar and follow the ruler all the way back to the y-axis so you can figure out what the frequency is. 12, 4, 6, and 8. We're going to fill those in here so we can use it for the rest of the question. Part B asks us to write down the modal class. Now these are the classes, the data classes. The modal class is the one that has the highest frequency. So the class with the highest frequency is the 0 to 5 class. Just make sure that you're writing it correctly. No equal sign underneath the left less than arrow because 0 is not included. There is an equal sign underneath the right one because 5 is included. The mid-interval value of the 10 to 15 class. So mid-interval value means the value in the middle of the interval. Now 10 to 15, it doesn't say that t has to be only whole numbers, right? So I've seen some people erroneously write 11, 12, 13, 14, and 15, thinking that those are the only possible values for t in this class. But t could have been 10.5 or 10.2, or 14.8. So it doesn't say that it has to be a whole number. We don't know that this is the list of options for t. So the best way to find a mid-interval value, just take the lowest value and the highest value, add them together, and divide by 2. So 10 plus 15 divided by 2, 25 over 2 is 12.5. 12.5 is the value right in the middle of the class that goes from 10 to 15, including all of the decimals between 10 and 15. But of course not including 10, and yes, including 15. That's included there when you add the two together and divide by 2. Then we're asked to use our graphic display calculator to find an estimate for the mean. I actually think it's faster not to use the calculator for it, but if you wanted to, you have to go into a list and spreadsheet and put this table into it, and then underneath some of the statistics features, you could find an estimate for the mean. But since you're going to have to fill in this table with a mid-interval value anyway, you're doing the work, you might as well just show the work by hand. So if you're finding the mid-interval value of each class because you don't know where the data points lie between 0 and 5, we're going to estimate that they're all around 2.5, and there were 12 of those. For the next class, we're going to estimate that it was 7.5, because that's the mid-interval value. There were 4 of those. For the next class, it would be 12.5, and there were 6 of those. And then for the final class, it would be 17.5, and there were 8 of those. So if you were going to do this on the calculator, you would need to be putting in 2.5, 7.5, 12.5, and 17.5 as your left-hand column. If you're going to do it by hand, just take that whole total and divide it by the number of telephone calls, right, the total frequency, which here is 30, and you'll get the average length of a telephone call, or an estimate for the average length of a telephone call. If you show this step, 275 divided by 30, you run the ability to get some partial credit, rather, even if your final answer is wrong. You would get 1 point for having division with 275 shown. And then 275 divided by 30 comes out to 9.17 if you round it to 3 significant figures. And that's the answer that they were looking for. Don't round to less than 3 significant figures, because it doesn't say in the problem what we should round it to. All right, next question is a trig question. They show us this 40-degree angle of depression from somebody who's standing at T and looking down at this ship over here. And then they tell us there's another angle of depression, 55 degrees, from the person who's standing at T when they look down at a fishing boat. That would be the angle from here to the fishing boat hypotenuse, right? So an angle of depression is always between a horizontal line, which is where your eyes would be looking if you weren't going to depress them at all, so if your eyes just look straight, and then if you lower your eyes down to look at the fishing boat, that's the 55-degree angle that your eyes are turning through, right? So there's the 55. What that means, based on the location of where that 40 and where that 55 is, just fix that. Okay, so there's the 40, there's the 55. Here's the 40, and here's the 55. Because of alternate interior angles, right, T, the line up here, is parallel to the line down here that represents the water. So because of those parallel lines, we have some alternate interior angles that we can label. If the one between T and here is 40, then this would also be 40. And if the one between T and the fishing boat is 55, this would also be 55. So those are really the angles that we're going to want to use. I can erase all of those labels up there. I just needed those to accurately fill in the angles here at the ground, or I guess at the water. Now it asks us to calculate SB, which is the distance from, clear off the bottom of this, the distance from S to B. So they're pretty clear about what they want you to find. So they give you the letters so you're not going to find the wrong side by mistake. Distance from S to B, the ship to the bottom of the cliff. For that one, I would consider TSB or TBS here one big right triangle. You know this is 40 degrees. You know the opposite leg from that 40 is 150. That would be the height of the cliff. And we can find the leg that's adjacent to it using either sine, cosine, or tangent. Remember, if you have opposite and you're trying to find adjacent, we want to use tangent. So the tangent of 40 is the opposite leg over the adjacent leg. And then we can multiply by that SB to get it out of the denominator, and then divide by the tangent of 40. So SB is going to equal 150 divided by the tangent of 40. Go over to your calculator. 150 divided by the tangent of 40. If you get some kind of a crazy answer or a negative answer when you do this, just need to go double check that your calculator is in the right mode. It has to be in degree mode, not radian mode. Here I'm getting that SB equals 178.76. That's more than enough significant figures. And I'm going to put units on that. These are being measured in meters. So the distance from S to B is 178.76 meters. If you were to round this to three significant figures, 179 meters would be accepted. Okay? And the second part of this question asks us to calculate SF, the distance between the ship and the fishing boat. So between S and F. So erase the labels that we have here. It's getting a little messy. And I will fill back in that we have 40 here, just in case we need it again. We have 55 here. And we're now trying to find this distance. Well, we know the distance from S all the way to B. So hopefully it should occur to you, if you can find the distance from F to B and then just subtract it, you'll be able to get the distance between these two vessels here. So to find FB, we're going to repeat the same process that we just did, but with the 55-degree angle instead of the 40-degree angle. So we're going to say the tangent of 55 equals the opposite leg over the adjacent leg. And this time we're finding FB instead of SB. Multiply by that FB. Get it out of the denominator. FB will equal 150 divided by the tangent of 55. Head over to your calculator. We're going to do 150 divided by the tangent of 55. Hit Control Enter so I can get a decimal approximation. And FB is approximately 105.105. 0.03. That's also meters, and then to get the distance from S to F, I'm going to subtract my answer from part A, which was, I'm going to use the more precise one, so that I can be sure I'm being as accurate as possible. Subtract these two, we've got 178.76 minus 105.03. And the distance is 73.7 meters if we round it to three significant figures. Oh, glad I looked. It does say give your correct answer to the nearest meter. So there's always going to be one question on paper one that gives a specific degree of accuracy. See if you're paying attention and see if you know how to round correctly. So correct to the nearest meter would be to the nearest whole number, so 74 meters is actually the answer that they're looking for. 74 meters. We would not be able to get full credit if you didn't round this correct to the nearest meter. Okay? Then we have a logic question. P statement is that Alex is from Uruguay. The Q statement, Alex is a scientist. And the R statement is that Alex plays the flute. We're first to write the following statement in words. The negation sign in front of the R. And then there's this double bar with an arrow going forward. And then in parentheses, we have Q or P. So remember that if you've got this symbol, we're going to call it if at the beginning and put a then in the middle. So we've separated our statement into an antecedent and a consequence. So I'm going to try to write this here, see if I can fit it. Okay, so to write this thing in words, we're saying if, because I see that arrow going forward, we then need to start my statement with an if. If, then we have not R, right? That means negation R. So if Alex does not play the flute, okay, negated the R statement, comma, then, now when I have in parentheses Q or P, the answer key to this is pretty clear that they want you to use either or to make it clear that the Q or P is grouped together in these parentheses. So we want to say if Alex does not play the flute, then either Alex is a scientist or is from Uruguay. So if you had just then Alex is a scientist or is from Uruguay, it's not clear whether that or is from Uruguay piece is included with the Q or if it's just kind of hanging there at the end of the if-then statement. So we want to use either or to show that the Q and the P, the Q or the P, excuse me, are grouped together. I know that's a really picky detail, but we want to be as precise as possible. For part B, we're just completing a truth table, so it almost doesn't matter what the statements are here. We're just going to look at the truth table. They've already filled in the first 4 columns for us. This one is a Q or a P, and remember, in order to have an or be true, just one of the 2 statements needs to be true, or both. So we have 2 of them being true. That makes it true. That makes it true. In both of those, one of them is true. In both of these, one of them is true. And only here and here would this or statement be false. And then the final one is an if-then. We have this conditional statement here with not R as the antecedent, right? So this is our antecedent. And then Q or P as the consequent. So Q or P as the consequent. So we're looking at the not R column followed by the Q or P column. And remember, the only time that an if-then statement is false is when the initial thing is true and the final thing is false. So the antecedent is true, but the consequent is false. And if you don't remember this, there's a general guideline to it in your formula booklet that you can always consult. So here we have a false followed by a true. That would be true. True, true is true. False, true is true. Remember, if it starts with a false, it's automatically true for an if-then statement. So we've got true, we've got true, we've got true, we've got true, even though that one was false, false, right? If it starts with a false, then it's a true if-then statement. And only one that gets to be false here is the final column, where it's a true followed by a false. And then in part C, it says the argument is invalid. They're kind of giving that away just in case you got the truth table wrong. They want you to still be able to get this final mark. So the argument is invalid. State the reason for this. There are lots of ways you can say it. The way that the answer book is looking for is that not all entries in this final column of our truth table, in the argument column, are true. So not all entries in the final column are true. And there are other ways to say that. They might accept the argument is not a tautology because not all the statements are true. In some way, you need to get across the idea that you have one false in that final column, and therefore this is an invalid argument. Then we move on to a descriptive statistics question. All right, they give us a data set, XY table, and they plotted it already on a scatter diagram for us, so you don't have to draw the scatter diagram yourself. Writing down the coordinates of the mean point, mean of x and mean of y. You can, of course, calculate the mean on the calculator by adding 2 plus 4 plus 7 plus 12 plus 4 plus 8 plus 9 plus 2, and then dividing by 8. And then do the same thing for the y. Since, however, you're going to need to calculate r in the next question anyway, you're probably better off typing in the x and the y data into a list so that you can use the statistics features of the calculator. So let me add a list and spreadsheet page here. Press menu. I want to add a list and spreadsheets page. If you're on an Inspire, it's important that you name your two lists. On the TI 83 or 84, they'll be called L1 and L2. So I'm going to name mine X and Y, which is the name given for the data here, right? So X and Y. Then I'm going to go into the first column and type in all my X data. 2, 4, 7, 12, 4, 8, 9, 2. Okay, good. I have 8 pieces of data. That is what I was expecting. And then I've got 5 for the Y, 8, 12, 26, 12, 14, 20, 7. Okay. So to calculate the mean of the X and mean of Y, I can just go to menu now, go to statistics, and I'm looking for stat calculations, 2 variable statistics. I have X and Y, so I'm going to go to my 2 variable statistics. It's going to ask me to choose my X list, which I called X, so it's on the drop-down menu, and it's going to ask me to choose my Y list, which I called Y. It's going to ask us where we want to put the results. This final thing here says first result column. Sure, let's put the results into the C column. I don't have anything there yet, and hit OK. So now it's got a long list of results. See, I keep scrolling down. It gives us all these important statistics. What am I looking for? Mean of X, mean of Y. So the mean of X, it even shows it to you right here on the exam, is the X with a bar over it. So the mean of X here is 6. I'm going to scroll down and find the mean of Y. It's the Y with the bar over it, and that is 13. Okay? So you get a mark for having the X mean right and a mark for having the Y mean right. Then it asks us to write down the value of Pearson's correlation coefficient, so R. We don't have R on this screen. We haven't chosen the right statistics calculation here. Oh wait, we do have R on the screen. This is great. So in the 2 variable statistics screen, it actually does give you R. Another way to do it would be to go find the linear regression, which we're going to have to do in the next step anyway. But we have R on this screen, so we can trust that it's correct. It says it's 0.952. R equals 0.952. That is the minimum number of significant figures that will get you the credit for this question. You cannot write 0.95. The 0 is not significant. So you need at least 3 digits after the decimal point that are non-zero. So we've got 952. And then draw the regression line for Y on X. In order to draw the regression line, I want to plot the mean point. So 613 is going to be here. 1, 2, 3. They're first looking to make sure that your mean point is labeled correctly there, or at least it's located in the right place. And then your regression line needs to go through that mean point. The other part that needs to be accurate about your regression line is where across the y-axis needs to be accurate. So you should have 2 points that are accurate, the y-intercept and then the mean point. And if you draw the line connecting those 2 places, you'll get full credit for this line. So I just need to figure out the y-intercept of the regression line. So I'm going to ask my calculator to get me the equation of the regression line. I go into Stat Calculations, Linear Regression, choosing my X for X list again, okay, choosing my Y for Y list, scrolling down my first result column. Let's see, E should be fine. I have stuff in A, B, C, and D, so it's going to move it over to the side, put it over here at E. See what it says for linear regression. I have to scroll up and find this information. So it gives us M, and that's the slope, and it gives us B. So if the regression equation is Y equals 1.87x plus 1.8, this one is the location of the y-intercept, right? The B in y equals mx plus b is the y-intercept. So I need to put 1.8, plot that point on the y-axis. So somewhere between 1 and 2, I need to have a point. Okay, and then take out your ruler, be as precise as possible. I don't have a ruler open right now, so I'm not going to take the time to do it. But when you graph this, take out your ruler, connect your y-intercept to your mean point, continue it to the end of your graph, and that's how you'll get full credit for this regression line for part C. Okay, so what are they looking for there? They're looking for you have a straight line that passes through the mean point, that passes through the y-intercept at 1.8 to get the full marks. And let's do one more question on this video here. All right, we have a basic kind of function analysis, kind of calculus question here with no numbers. So we're just asked to think analytically about a function that does this. So write down all the labeled points on the curve that are, for A, local maximum points. I think this one's pretty clear. It's anything that's at the top of the hill, anything that in its area is the highest point, because the points on either side of it are lower. So we have a maximum point, local maximum point at B, and we have a local maximum point at F. So it's 1 mark if you have those both written. It's no marks if you have anything else written, either more or less points. For part B, write down all the labeled points where the function attains its least value. That is an extreme statement. That means the lowest value on this function. And this function doesn't continue past it to the left or past it to the right. The function is just what we're looking at here, and it attains its least value, meaning its lowest y value, its lowest function value, at h. The function attains its greatest value, so the y value is its absolute highest at point F. B no longer gets to go on this list because even though it's a maximum in its area, it's not the maximum of the whole function. Where the gradient of the tangent to the curve is positive. So that means, if you think about it, at the point that you're looking at, is the function rising? Because then it would have a positive gradient for the tangent to the curve at that point. So like when I look at point A, it looks to me like the function is rising as it goes from left to right. So the tangent line would have a positive slope. So A is going to go on this list. At B, the tangent line would be flat. That would have a 0 gradient. At C, the tangent line would be a negative slope. At D, it would be flat. At E, it looks like the tangent line is going to have a positive slope. So we'll put that on the list. At F, it's 0. At G, it's negative. And at H, well, actually at H it would be 0 because it's not doing anything at H. The function has stopped moving. Okay. That's it then for D. So only at point A and point E would the tangent line have a positive slope. And then part E is just worded in a confusing way, but it's actually pretty clear if you have it translated for you by me. It says where f of x is greater than 0 and f prime of x is less than 0. So I'm going to interpret this to mean the function, which means our y value, right? Function is positive. That's what it means to be greater than 0, right? So where do we have a y value that's positive and a slope or gradient, that's what f prime is. F prime is the slope, less than 0, which should mean is negative. So we're looking for any points that have a positive y value and a negative slope. I see one right here, right? The y value there is positive, it's above the x-axis, but the slope is negative. All the other places that have a negative slope are below the x-axis. It's actually just this point over here, right, point G. It's the only thing that gets to go on the list for our E is the point C. And that one is worth 2 points. You have to either have C or you don't have C, so there's no partial credit on that last question. Okay, I'm going to stop this video here so we can break this thing up into pieces, and I'll pick it up with number 6 in the next video.